Hello, my name is Santosh Kumar Bibi, PhD student in Transportation System Engineering, Department of Civil Engineering at ISC Bangalore. My study is mainly focusing on optimizing scheduling strategies for the multimodal public transportation, particularly emphasis to the buses and the metros in the Indian cities. The main background and the motivation of the study is there is a lack of service quality in the public transportation in the most of the Indian cities due to the various reasons. Due to the increasing in the rapid urbanizations and the people who are shifted from the public vehicle to the private vehicles due to the various reasons such as irregular schedules, unreliability, improper scheduling, and overcrowding and safety and other concerns. So that once the people are shifted from public to the private, it will also increases the congestion, pollution, and the travel delays and all. So the main focus and the main problem statement of the current study is to improve the service quality of the public transportation and improves the reliability aspects and all, so that we can come back the people who are shifted to the private vehicle, we can come take back those passengers to the public transportation. It will reduces the congestions and the air pollution and improves the overall performance of the city level. And one more thing is we have seen that there is a lack of poor service quality in the urban transportation. Most of the bus punching will be happening in the bus stops. We are seeing that at a particular time when we go and stand in the bus stops, there is a lot of buses in the same number bus routes comes 2 to 3 buses will come at the same time. But at the same after sometimes we can wait for up to the longer waiting time also. There is none of the buses will come at a particular stops. To overcome these problems, and sometimes there is a overcrowded happening in the peak hours, and some of in the same route in the non-peak hour there is a free empty buses will also going on the same routes. So these combining these several problems, my study is mainly focusing on improve the performance of the public transportation and also optimizing the scheduling of the buses based upon their crowding aspects and all. The study also introducing the dynamic scheduling of the public transportation also. From the various research literature, you can find several steps such as there is a limited integration is going on the passenger and operator. Study is going on the integration of the passenger operators and the stakeholder and the community aspects in the public transportation, and there is also insufficient for studies is focusing on the combining the both primary data and the secondary data sets and making the index formations and all. And there is a lack of operational reliability indicators such as waiting time schedule and all. And there is integration of static and dynamic scheduling. The main aim of the study is to develop integrated data-driven framework for evaluating and optimizing the performance of the urban transportation system in Indian cities, and the optimizing techniques to improve the reliability, efficiency, and service quality of the open network everything. And based upon these aim, the current study will be making the 3 different objectives. First one is to finding the performance evaluation of the public transportation at the route level and the network level using the primary data and the secondary data sets. Then we can go for the optimizing the scheduling of the public transportation at the route level by using the static data sets and all. Then we can go for third objective is go for the optimizing the bus scheduling based upon the dynamic timetables and all. These were the data sets. In my first year of the PhD, I completely collected the data set and the pre-processing of the primary data set as well as the secondary data sets. Primary data set including the survey data collected from the operators, the users, and the stakeholders. And the secondary data includes the ETM data, electronic ticket machine data collected from the agencies, and the GTFS real-time data as well as the static data and the land use patterns of the particular cities. Currently the pre-processing of the GTFS real-time data is going on. Each day of the GTFS real-time data includes the 60 million entries per day. They have 126 days of the larger data we have. Currently we are going to cleaning these data sets based upon some of the things and all. Then after that, using the GTFS real-time data, we can find the degree of centrality and the degree of centrality of the GTFS static data. The degree of centrality shows that in a particular stop number of routes will be diverging from the particular stops. It is called as degree of centrality. The between centrality means the number of stops will come in between the total number of routes. So that is considered as the between centrality. These were the top 20 centrality, degree of centrality, and the between centrality of the Bangalore cities. And then we can also consider analysis the comparative study of the impact of air in Bangalore in public transport ridership in the Bangalore due to in the early quarter of 2025, the government of Karnataka has increased the fare of up to 20% in the BMTC bus agencies and up to 50% in the BMRCL metro agencies. So what is the effect that can happen in the ridership? We can collect the data from the public as well as the travel demand survey model. We can get that there is a decline in the 5% of the metro ridership due to the increases in the fare hikes and all. Then after that, currently we are estimating the missing arrival time at the stops by using the merging the static data and real-time data. Static data, which includes the stop level information, route level information, and the trips and all. Real-time information, it can having the particular GPS of a particular bus's latitude and longitude. By merging these data, we can finding the missing it of the arrival times and all. Then future work is once we can calculate the travel time reliability, travel time variability, and the crowdingness of the buses and the land use data patterns. By merging these secondary data set with the primary data set we collected from the survey data, then we can make a performance index for the route level at the network level. Then we can go for the static scheduling optimization by using the multi-objective optimization. It includes the various variables such as minimizing the waiting time, minimizing the in-vehicle travel time, and minimizing the travel cost and various aspects. Then we can go for the dynamic scheduling of the using real-time data sets. Thank you.